Properties of logarithms. All right, these properties that I'm going to explain to you only apply when the bases are the same. You're also going to notice that a lot of what we do now is going to be very similar to what we did with exponents. So some of these rules might seem a little bit familiar, and that's because they're very similar to exponents. All right, the first property is the product property. Here's what this looks like. The log base b of m times n, let me put a little times in between there, is equal to the log base b of m plus log base b of n. So if you have two values that you're multiplying together, you can actually break those into two separate logs by adding. And vice versa, you can go back and forth between the two of these. Let's practice a couple. Alright, so what we're going to do is we're going to add logarithms. We're going to express as a single logarithm, meaning I only want to see the word log once. Notice that there is an addition sign. So what I'm going to do is I'm going to put these together, log base 6. Also notice that the bases are the same. That's very important. So log base b of 6, or log base 6 of 4 times 9. Multiply that to get log base 6 of 36, and then using what we did previous, see if we can simplify this. A couple different things you could do. One, you could just rewrite this as log base 6, change the 36 into 6 squared, so then all of this just cancels out and it equals 2. Or you could rewrite this log base 6 of 36. You could set it equal to x and then change it to exponential form. 6 to the x power is equal to 36, and balance out the bases. 6 to the x equals 6 squared. Same thing, you'll get 2. Let's try another one. This time I have natural logs, which, remember, those have a base of e, so they are the same. Since there's an addition sign here, I can put this together. Natural log, I don't have to write that e, of x times 2. That looks kind of funny, so I'm going to write natural log of 2x. And this time I can't simplify anything, so I'm just going to leave it like that. The next property is the quotient property. Remember, quotient, usually see division here. So this property is going to look like this. Log base b of m over n is equal to log base b of m minus log base b of n. So if you're dividing, you're going to split that up with a minus sign. And it's always the top value minus the bottom. So whatever's on top minus whatever's at the bottom. Alright, let's try a couple of these. First one is, and notice, always double check that the bases are the same, because if they're not, then you can't do any work. So I've got log base 5 of 100 divided by 4. I can simplify that into log base 5 of 25. And again, a couple different things you could do here. Log base 5, see if you can rewrite 25 so it's 5 to some power, 5 squared. So this equals 2, because remember, all of this, if the base and this number are the same, they cancel out. Or you could write log base 5 of 25, set it equal to x, change it to exponential form, and balance out your bases. You'll get the same answer, so it really doesn't matter which way you do this. You'll get 2 either way. Alright, let's try another one. Alright, so notice the bases are the same. That's good to go, and we have a subtraction sign. So I'm going to rewrite this as log base 7 of whatever's first, which is x to the 4th power, divided by y. Notice there's really nothing I can do with this, so I am going to stop there. Let's go on to the third property. This is called the power property, which means we're going to have an exponent. So if you see log base b of m to the nth power, this n, this exponent, is actually going to jump out in front. And you see it right here now. Vice versa, if you wanted to go backwards, you could always make something in front of a log, whatever's being multiplied, you can move it up to make it an exponent. Let's look at a couple examples. In this first one, I'm going to rewrite this because it's so small. Alright, so log base 2, 32 to the 6th power. You could just take 32 to the 6th power, but you're going to have such a huge, ginormous number, it's going to be very difficult to work with. So if I take this exponent, this 6, and I move it out in front, it's going to not be quite as nasty to work with here. So let me rewrite this. We have 6 times log base 2 of 32. So now I'm going to try to simplify the log base 2 of 32. You can do this a couple different ways. Leave that 6 there. I am going to write log base 2, and I'm going to try to rewrite 32 so that it's 2 to some power. So, if you need to, get your calculator out, type 2 to the 4th, 2 to the 5th, 2 to the 6th. You will see, fairly quickly that 32 is really 2 to the 5th power. As long as your base and that number are the same, it all just cancels out. So right now you're left with 6 times 5. So my answer is 30. Let's try another one. Again, I'm going to rewrite it because it's so small. So log base 8, x to the 5th power. I'm going to take this exponent right here, this 5, and I'm going to move it out front, making it look like this. 5 times log base 8 of x. Really nothing else I can do with that, so I'm done. And again, that might seem kind of silly, but looking at example A, it just sometimes helps us work with smaller numbers or break the logs up a little bit. Alright, let's practice condensing into a single log here. So you're going to see now that we might use more than one property or kind of mix them up. So always double check that your bases are the same, though we've got base 4 on both, so we're good. I see a minus. If you see a subtraction, that means to take whatever's first, so start with log base 4, whatever's first, and divide it by whatever is second. Really nothing more I can do with this, so I'm done. I have one log. I followed the directions. Let's try the next one. Right now I can't do anything because there is a number in front of these logs. They did have the same base, so that's good, but I have to get rid of that 6 and that 2. The last property we worked with said that I could actually take that number in front of the log and make them into exponents. So I'm going to rewrite this as log base 2 of x to the 6th power plus log base 2 y squared. So now I don't have any numbers out in front, I just have logs by themselves with the same base, and I have an addition sign. So remember, the first property we worked with said that you could take anything with an addition sign and combine the logs with the same base by multiplying. So I've got x to the 6th times y squared. Again, nothing else I can do with this, so I'm going to just be done. Let me point out too that that little dot there you really don't need, so I'll erase it. But I just wanted to show you it meant times. Let's try a couple more. Alright, on C, notice that I have 4 different parts to this, so it might be a little bit more involved. Always make sure they have the same base. They're all natural logs, so they all have a base of e. And then look in front of the logs, look before them. This second log has a 3, so I'm going to make that become an exponent, and I'm going to rewrite this. Natural log of 4 plus the natural log of 2 cubed, that's an ugly 3, minus the natural log of 12 minus the natural log of 8. A couple different ways we can look at this. Whenever something is subtracted, that stuff's going to be in the denominator. So I'm going to end up with a 12 and an 8 in the denominator. Another way you could look at this is to take and just put these first two together. So I've got the natural log. Since it's an addition, I'm going to multiply these. Keep in mind that that 2 cubed is really an 8 right there. So that 2 cubed is really an 8. So I've got the natural log of 4 times 8. I still have minus ln 12 minus ln 8. I'm going to factor out that minus sign. So now I have natural log of 12 plus the natural log of 8. Now I can put these two together. Let me rewrite this. So I've got natural log, 4 times 8 is 32, minus, I don't need the parentheses anymore because I'm just going to write 1 natural log, 12 times 8. Rewrite this again, natural log of 32 minus the natural log, 12 times 8 is 96. So finally now I just have 1 natural log minus another natural log. So I will rewrite this as the natural log of 32 over 96. Yes, I want you to reduce that fraction if possible. So I am left with the natural log of 1/3. And that's about all we can do at this point. Let's try another one. All right,